Today is the second day we will be graphing linear inequalities into variables. In today's lesson, we're going to be looking at word problems. The first word problem says you have $24 in your pocket when you walk into the arcade. Arcade games cost $2 each and snacks cost $4 each. Now also, within this problem, they told you what variables they want you to use. So they want X to be for arcade games and Y to be for snacks. The first part, Part A, says to write and solve an inequality for the above scenario. So we know that we have $24 in our pocket, so that's kind of our end game. We have $24 to spend, and we have two things we can spend our money on. We can spend it on our arcade games, which cost $2 each, and arcade games, like we said, is shown with the variable X, so $2 per arcade game. And we also know we have $4 for snacks, plus 4Y. And we know we only have $24. So I can spend $24, I can spend less than $24, but I can't spend more. So it's going to be less than or equal to. So everything going on the left-hand side has to be less than or equal to 24. Now in order to graph this, I need to solve. So I need to get y by itself. So I'm going to subtract 2x from either side. And I have 4y is less than or equal to negative 2x plus 24. Now notice I put the 2x first because I want this to look somewhat like slope-intercept form so it's easier to graph. Now I'll divide both sides by 4. And my final inequality is y is less than or equal to negative 1/2 x plus 6. So we're done part A. Now in part B it says to label the axes and graph. Now we know that this is our x-axis and this is our y. So we're going to label that. So I'm going to have arcade. It's going to be the number of arcade games, right? It's not going to be how much they cost. We know how much they cost. Number of arcade games. And my y-axis is going to be snacks. And again, that's the number of snacks, not how much they cost. We know how much they cost. Okay, number of snacks. So now I have to graph it. So my y-intercept is 6. So I'm going to start at 6. 1, 2, 3, 4, 5, 6. I'm right here. And my slope is negative 1 over 2, so I'm going to go down 1 to the right 2. So I go down 1, 2 to the right, down 1 to the right 2 is here. Down 1 to the right 2. And I'm going to keep going. And then I have a solid line, right, because I know I can spend $24, but I need to spend less than that. So I'm going to graph using a solid line. Now, I'm not going to put arrows on the end here because if I were, it would say that I could have like a negative number of arcade games or a negative number of snacks, which I can't. It either has to be 0 or a positive number. Now, if I go back to my inequality, I notice that it's less than or equal to. So that's going to be below the line. So again, this is above and this is below. If we do my marble test again, my marble test, anything above is where the marble would stay. The marble would kind of go along this line. Below, if I did the marble test, it would drop below the graph, so I know that's below. So I'm going to shade in here. Okay, so anything in the shaded region along with anything on my solid line is going to be part of my solution set. Now my last part, Part C, says to give examples of the solution to the inequality and what does it mean. So really anything in here is going to work. I'm actually going to number this. I probably should have done this early, but that's okay. I'll do it now. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll just kind of go up and I'll do the same thing on my y-axis. Just number them so it's a little easier to see. And then I'll just make a decision. So I can have like this point right here, 0.23. That's part of my solution set. So it means I can play 2 arcade games and I can buy 3 snacks. So I'm going to just write that I can buy 2 arcade games and 3 snacks. I'll have enough money to do both of those things. Anything in here will work. I could do 6 and 1. I could say that I could buy 6 arcade games and buy 1 snack. I could go the other extreme here and only just do 1 and 1. So anything in there will work as long as I'm spending less than or equal to $24. Our next word problem says you have at most $26 to spend at the homecoming football game. Entrance fee is $5 and it costs $2 to play each carnival game, which we're going to show as X, and $3 per drink or snack, which we're going to show as Y. Now again, we're going to do a few things. We're going to write and solve the inequality, we're going to label, and we're going to graph it, and then we're going to give 2 examples. So let's start with our inequality. So again, I know I have $26 to spend. That's my end game. And I know I'm doing a couple things. I have to pay $5 to get in, so here's my 5, plus $2 per each carnival game, which is X. So I have plus 2X. And in addition, if I want to buy a snack or a drink, they're each $3. So that's going to be plus 3Y. Now again, I have $26 to spend. I don't have more than that, so I have less than or equal to. Everything on the left-hand side right here has to be less than or equal to 26. Now again, to graph, I'm going to try to put this in slope-intercept form, so I need to get y by itself. So first I'm going to subtract 5, bring that to the other side. I'm going to do it all in one step here. I'm going to subtract 2x, so I get my y by itself, so I have 3y is less than or equal to, and I'll write it in slope-intercept form, negative 2x plus 21. I need to divide everything by 3. So my final inequality that I'm going to graph is y is less than or equal to negative 2/3 x plus 7. So 7 is my y-intercept. My slope is negative 2/3. So I'm going to go down and to the right. So there's my inequality. So that step's already done. In my second step, it says part B says label, and I need to label the axes and I need to graph. So again, this is my x and this is my y. My x, I was told, is the carnival games. So again, that's the number of carnival games. Number of carnival games, and I'll number my axes this time. So I have 1, 2, 3, 4. I'll just kind of number it up to what I have. And then my y-axis is going to be, they tell us that's for the number of drinks and snacks. Drinks and snacks. And again, I'll number that. So I have 1, see how far. So I'm all set there. Now I'm going to graph. So I start at 7. So here's my y-intercept at 7. And my slope, I'm going to go down 2 to the right 3. So down 1, 2 to the right 3. Down 2 to the right 3. Down 2 to the right 3, and I'll just kind of keep going. And again, that's a solid line because I have less than or equal to. So I'll draw my solid line through my points. And again, it's less than or equal to, so I'm going to shade below. And similar to my last problem, I'm asking for 2 examples. Like, what can I buy when I go to this homecoming football game? Anything in here is fine, anything in my shaded region. So if I use the points 4, 2, then that's allowing me to buy 4 carnival games, play 4 carnival games, and I can buy 2 snacks or drinks. If I pick another point, let's just say I pick a point here. That can be 7, 0. I can do that. That means I can play 7 games, and no food. So 0 snacks or drinks. Maybe I ate before I left. Maybe the line's too long. Maybe I don't like what they have. So I'm going to spend all my money on carnival games, which is certainly fine because that 7, 0, that .70 is part of my solution set since it's in the shaded region.